Yeah, good evening, everyone, and I welcome you to this session on data science. We are going to get deep dive into the world of data science. Okay, some good mornings are also there. Probably they are from the other part of the world. So, good morning. A very happy new year to each one of you. We'll just wait for a few minutes because people are still joining in. All right. Great to see a good crowd. My apologies on behalf of the Institute for postponing the program by a few weeks. As you know, these programs happen very rarely. We wanted, we received requests from a few participants that they might join from the first week of January. And that's where I think we had to push the program. Nevertheless, we'll try to see that we will try to see that the learning is enhanced, and possibly, if required, we will do a little bit of extension also, depending on the participants' response and depending on the time constraints for the participants, etc. So everything can be customized as we move forward. All right. Yeah, the recording is done instantly. And what is the process in terms of uploading? Possibly you can get in touch with Ravindra. He would explain you the process, Keval. I don't think there is any other question to start with. I think everything is about the introductory messages itself. Right. I would also check with Ravindra and I can update you. Yeah, PPT will be shared, but most of the times I don't prepare that comfortable PPTs. I'm very bad at preparing PPTs, right? Because most of the times I prefer writing things on the whiteboard, which is like a PPT screen. But yes, the basically we would be working with Python in this program, as I'll be introducing you to all those things. Basically, we would be working with Python, and that's where I would be sharing all those notebooks with you. Great, but Keval, somewhere I don't get connected with PPTs that heavily. I might be slightly away from. Uh, that way, I'm slightly lagging or mostly lagging behind. I would always prefer to write out something so that it gets connected well. Okay. We shall continue to connect at this time every session. I don't know. That's a very, my request would always be for 6:30 to 8:30 rather than 7 to 9. Uh, because of an unusual request, generally I hit the bed by 9 p.m. So that's where I was requesting possibly if I can go from 6:30 to 8:30. But yeah, I do understand that the timing is not comfortable. But I can't help. I can't take classes on weekend. That's my limitation. So either early in the morning or late in the evening. I mean, late again, I can't extend beyond 7 o'clock. Yeah, so possibly we'll try to work it out. And because there is a recording, to a large extent, you can go through this video at your comfortable time as well. Right, video recording will be available under the member login. You are right, Sandeep. Okay. I don't know right now. Not sure. Possibly the institute may have to circulate, and I don't want. See, right now everyone has agreed for 7 p.m. to 9 p.m. So right now we will go ahead with the same timing, right? Rather than trying to fiddle out, right? Because some people are working professionals. So let's try to. I mean, if at all we require a change, we'll try to look into it. But as I'm telling you, I mean, at the end of the day, it's very difficult to convince every participant. So IAI has announced one timeline. I mean, with one timing. So probably let's stick to that. Whatever are the constraints each one of us are having, let's try to iron it out. And because the recordings are available, so possibly you can very well plan things accordingly. I would always, I mean, my personal preference is always early morning because I wake up by 3:30 a.m. every day. So yeah, let's keep things aside. Let's get into the content first. Okay. Uh, it was mentioned that we won't get certificates if we don't attend all live sessions. See here, let's understand two things. I mean, see here, there are two ways of looking at it. One, yes, to whatever extent possible, you try to attend. But the second one, we can also work out on a route where we talk about a couple of assignments, and in case you are able to successfully complete that assignments also, we can very well think of consideration. But this time the certificate would be mostly a participation certificate rather than a merit certificate. So it does carry some value, but definitely a merit certificate after passing some exam or something like that would have a different value. But I think this time the institute is planning to go ahead with the participation certificate to whatever extent it is possible, to whatever extent you can attend, you try to attend. Otherwise, listen to the videos and probably try to solve one or two assignments, the same end-to-end assignment. That could also give you some kind of a comfort as such. Okay, Suchandra, Kundu. Yeah, Ravindra can get back to you because we have a mechanism of sharing with non-members. So Ravindra will get back to you on that. Then any book required? Yes, there are multiple books that are available in the market. I will suggest a couple of books for you. But definitely for these kind of courses, getting your hands wet is the easiest solution, right? So basically you can try following my notebooks and try to build on the top of them by using some additional data that comes into your this thing. Okay. I am not in a position to answer your question, Keval. I am not equipped with information to answer your question. Right? Possibly you can get back to the institute to get these answers, or possibly I'll see if I can put you on to the right person. Right? I don't think I can answer this question right now. I'm not aware of it. Okay. I see a few hands being raised. I don't know how to look at that. Okay, lower all hands. I'm not able to see this. Possibly you can send it as a message. It would be, I mean, unless you want to speak out explicitly, but otherwise you can send a message or you can put it in a Q&A. Yeah, we can have a WhatsApp group, but I don't know. Possibly I'll ask Ravindra to create one. It can really help. Yeah, while asking questions, would it be yes? We can very well enable the mic, right? The only thing is we were thinking that because this is getting recorded, possibly the recording would have a lot of disturbance if multiple people speak. But definitely we can very well enable. So I can enable for you, Subramanya Shastri. I'm only not able to see you raising the hand. So if you want to talk, I can enable you. But yes, we will. I'll just have a quick introduction before I open it to you. So today's session is primarily an expectation setting kind of a session, right? In case we get some additional time, we would definitely utilize it for the actual session. But otherwise, we will start off with an expectation setting. Possibly a WhatsApp group we will plan. We will. I'll ask Ravindra to create that WhatsApp group with a list of members, right? But yeah, we will restrict it to only very relevant kind of posts and possibly some exercises, some knowledge sharing in the group. Okay. All right. So just wanted to give you a quick introduction into this course. I hope many of you might have gone through the curriculum that was shared by the institute on the website. My name is Vamsidhar Ambatipudi. You can call me by my first name, Vamsidhar, or sometimes people even shorten it and call it Vamsi. So it's up to you. Then I have done my BTech in computer science from Andhra University College of Engineering, Visakhapatnam, way back in 1999. And after that, I did my MBA from IIM Indore. I passed out in 2001. I'm a fellow of Institute of Actuaries of India. I am a SERA holder, Enterprise Risk from SERA Global, US. Then in the risk management area, I'm a qualified financial risk manager from GARP, US, and a professional risk manager. Early, I have conducted trainings for the institute. I think I have done a few exam paper related trainings. The finance course, the business finance, and possibly the CM1 and the CM2, the Excel aspects of CM1 and CM2. So some of these courses I have conducted the trainings and we have recorded them as well. And apart from that, I think I have conducted the machine learning training also earlier before this. Machine learning using Python. Now I think we are getting into the deep dive into the data science. Apart from that, if you are interested in some of the areas of finance, business analytics, machine learning, etc., or the exams like CFA, FRM, and actuarial science papers, you can very well refer to some of my videos that are there on YouTube as well. So I have around 1500 hours of content across these various exams and skill sets based trainings. So you can just type in my name in YouTube and you will get the channel for the same. And apart from that, if any one of you are interested in having some of these trainings to your employees in the organization, we can very well work out on that as well. All right. So getting into this deep dive into the data science. So just opening the curriculum which the institute has shared with all of you, right? we would quickly look at what is that we are trying to cover. So broadly, if we really look at, we are going to get into the introduction. What is data science? Primarily, we are going to deal with this course in Python. You can very well do this course in R, you can very well do this course in Julia, you can very well do this course in some other softwares also. Whereas here we are primarily choosing Python as a medium. Now, even if you are new to the world of Python, no worries. We are going to spend the initial few sessions on the basics of Python. The only thing is possibly you may have to work a little bit extra to get a hold on it. I would be sharing all the notebooks, the code books, which I would be working on in the class. Then obviously a little bit of math and stats is required. So we will be covering a few elements of essential maths, descriptive statistics, inferential statistics, something that is from your actuarial papers, but with practical data. So the entire course will be a practical hands-on. We will cover the theory wherever required. Then we would move on towards the machine learning. This was, in fact, there was a good amount of content that was covered when I took a machine learning training. So there will be some amount of overlap with that training here, but definitely the data set will change, the examples will change, and because of that, the entire training might look different in case some of you have attended that machine learning workshop. So these are all, until here we are talking about the various aspects of machine learning. Then we are also spending a few sessions in time series analysis. Of course, time series itself could be a separate program, right? Time series analysis itself could run for a 20, 30, 40-hour program, which we are planning sometime later. Then similarly, we have in data science, we should also be knowing something about the text mining, the natural language processing, etc. So we are just introducing with a few sessions. Again, this itself could get blown up into a separate workshop in itself, natural language processing. Then deep learning, artificial neural networks, deep learnings, etc. So this is also one more area that can go much deeper, right? We are having one introductory area in that aspect as well, and we are also, this web scraping also gets combined with natural language processing. We'll integrate them. Then working with databases, right? Of course, this is also a separate area in itself, but definitely a part of data science. So we are trying to cover that dimension as well. So it might very well go that as we move along, a lot of things can keep getting evolved, and we might very well want to add them also to our kitty, and possibly some of them may get covered much faster, some of them may take more time, something else can get added. So I want to hear from you people in terms of any additions, deletions, or modification, so that we can completely, at the end of the day, it is this group who is intending to get value addition from this training program. So based on your experience in the industry or elsewhere, what are those additional pluses and minuses that you are looking at to this curriculum that has been shared? This is a typical traditional B school oriented curriculum, or you can very well say the corporate training oriented curriculum on data science. So in case any one of you have seen something else and are looking forward for including or excluding a few topics, please feel free to message it so that we can work around with it. Okay, so we'll spend a few minutes trying to understand your expectations from the program, right? You must have thought about something when you have enrolled for this program. So either you can type it out, or if you want me to unmute you, I don't mind unmuting you as well, because today's session initially is about setting the expectations for the program. So let's not use both Q&A and chat. I would prefer we use the chat rather than the Q&A. Don't use the Q&A. All of you can use the chat window, and probably you can try to post your questions on that window. We will try to address them. Okay, so I'll go one by one. Which one is the most preferable programming tool? I think going by the industry standards, Python is according to my knowledge, Python is having the larger market share, because Python is mostly a general purpose programming language, which means on the other side, R is a more of a statistics heavy kind of so it's not a general purpose programming language. So what I mean by that is Python can very well be integrated with various other things. You can create web programs, you can create you can create lot of things. You can create apps using Python. You can create web programs using Python. You can create applications using Python. So it's a general purpose programming language, which is easy to learn and easy to apply. On the other hand, R is also easy to learn and easy to apply, but it is not a general purpose programming language. It is more and more a statistical oriented programming language, which means if I can't create apps using R, etc. I mean, nowadays possibly some extensions would have come up, but definitely it does not help me to create all those things. Though we are not talking about all those dimensions, but that aspect of general purpose programming language gives an edge to Python over the other tools. What is deep learning in addition to machine learning? So in machine learning, we will be seeing Keval so one of the tools of machine learning that we would be talking of is the artificial neural networks. Now, when we talk about it, we will be seeing that a lot of transformations happen to the data to try to find out the relationship between the input and the output. So if instead of one transformation, we talk about multiple transformations and multi-layered processing between the input and the output, multiple layers of processing happen before fine-tuning the output. That is what, in short, can be talked about deep learning. But yes, when we go into deep learning, we'll define it in a much more clarified kind of a manner. Would you please guide me regarding my question related to data science? In the decision-making process of an actuary, how should data science and actuarial tools be positioned? Can data science replace the actuarial tool? Now, I think this question is more easier to be answered. So there is a regulated dimension to every problem. One. Two, data science and actuarial tools, they are solutions to the same problem, right? They are solutions to the same problem. Probably I want to do a pricing of a product, or I want to do the premium. I want to compute the premium for a particular policy. Now, you have your own traditional methods, and we have, let's say we want to use the data science to solve that problem. Now, at the end of the day, one, how the regulator can be convinced for the usage of the model. 1. 2. How robust is the model? 3. What are the error metrics that this model is doing better compared to the traditional model? So at the end of the day, you are setting some kind of a metrics. And if by using the metrics, the model is outperforming the other models, then that is when it becomes a kind of a choice. At the end of the day, actuarial tools, they are solving the problem from one perspective, possibly the accuracy, the speed, a lot of things are associated. But by bringing in the machine learning models, by bringing in different algorithms, if the solution that is being generated is having a much better accuracy on the back testing that you perform, obviously you can position it as a choice. And if that works with all kinds of data under all environments, then possibly it can be taken up for even with the regulator, and then it can come in as a replaceable kind of a tool as well. So it's a part of the process itself, right? So it might very well be possible that some solutions, the traditional methods are still doing a good job compared to the machine learning, and so you will definitely find that. Wanted to learn and understand the use of various applications in the field of actuarial science. The examples that we are bringing in, to some extent, because we have participants from actuarial as well as the non-actuarial domains also in the program. So we will try to bring in typically some examples from the world of actuarial science wherever applicable, but we will have examples from the other domain as well. So which means you can very well relate the model that we are discussing with the domain of your expertise. Okay, let's now delete anything from this. Let's now delete. Since I have not used Python at all, let's now delete anything, not delete, right? So we'll not delete. Not a problem, Shubham Agarwal. I have no understanding. We'll try to go step by step, right? So we will see how comfortably, possibly initially we may go a little bit slow, but definitely I'm sure you will pull it off. Creating projects, yes, we will create. So what we are going with a hands-on approach itself, Jishu. So which means we are going to create some projects. Definitely, we would not go away from data science and get into app development, game developments, etc. Those also can be done with Python, but those are not my areas of expertise. But as far as data set is available, how well you deep dive into that data and try to pull out insights out of it is something which we will do. We will create some simple projects, and some of them you can take as assignments and work on them as well. Which library are we going to use? NumPy, sklearn. We are going to use NumPy, scikit-learn, and possibly I'll introduce you to TensorFlow. For machine learning algorithms, we are going to work with scikit-learn itself. And we would also bring in SciPy. We would also bring in stat tools. So we are going to bring in many other libraries as well, Sachin. Okay. To get a higher level understanding on various topics in the curriculum, yes, we are going to look into that. So anything that you are stuck, just get back to me, right? So I will try to position it in the next class. So every class, before we get into the new topic for the class, we will try to spend a few minutes trying to address the doubts and queries from the previous class. So that is how we are going to position. And in case we are able to work out with a WhatsApp group, I'm sure some of you can post the answers to the queries in that group itself, which would save time for me as well. learn data science or data analytics as a tool to help price and underwrite life insurance products. Yes. So I'll give you pointers. Okay, direct data is not available or data is scarce and unorganized. Okay, so possibly a more specific problem, because in data science, we are more and more looking at where data is available. Right? The whole world of data science is about where data is available. Otherwise, we talk about simulations, bootstrappings, various other dimensions as well. But in the world of data science, we are purely going with the availability of the data. Right? We are making our conclusions and inferences purely by looking at the data. Which editor is used to execute programs in Python? We have so many editors available, but I mean, my last program I have done on Jupyter Notebook, but this time I propose to use Google Colab, because kind of it's a kind of cloud-based platform, so installation issues and all will not crop up. So that is where I thought this time I would go ahead with Colab. So because you don't need any explicit installation at all, and it will connect with your Google Drive to save the things. So it becomes more easier. But if you say some of you are more comfortable with Jupyter Notebook, you can very well use them because there's not much of a difference in the editor. Okay, Nikhil Gupta, understand what is data science and the difference versus ML, to have a practical experience to assess how we can use data science to the data set. This is perfectly what we are going to cover, Nikhil Gupta. So I hope you will have good time. Okay, so the Nayan, we are going to work with some data sets. I'll share some of the data sets or project problems. So we will, you can try to solve them and you can share your experiences in the class as well. How to install and work with notebooks today? Yeah, we will do that. As I told you, Ashok, we'll use Google Colab. Right? In Google Colab, you don't need any installation. That's the beauty of it, right? So possibly as good as you type colab.research.google.com. So you simply type colab.research.google.com. Right? So if you already have created some Colab notebooks, Python files, they would be shown here. Otherwise, you can very well create a new notebook. That's it. So you can simply say colab.research.google.com and it will take you to creating a new Python document. Okay. So we will go more deeper into it, but that's as simple as that. So that is where I am preferring using the Google Colab for this entire program. Okay. I feel that our question should be related to the topics covered, as there is no limited to. I think that's the real point, Sandeep, because I mean, if there is some small addition or deletion to the topic, we can very well do it. But definitely unrelated questions, let's try to restrict them, or we can have a separate call. You can give me you can send me a message. We will be there in the WhatsApp group, so you can send me a separate message and all. So we can try to address, because for data science, the sky is the limit, and which means sometimes I may have to really do some kind of an external research to come back. Okay. I heard a lot of insurance companies are moving to cloud platforms like AWS. Yes. Frankly speaking, see, the algorithm will not change. The machine learning model will not change. The only thing is how it is deployed will have a big difference, according to what I understand. Frankly speaking, I have not worked much on those servers because so we have many such kind of servers: AWS, Azure, Microsoft Azure. So all of them, again, depending on which platform has been installed or which framework has been installed by the organization. But the framework of machine learning, the framework of data science cannot change. So we are more focusing on the framework and again using the tool like Python. But the implementation part of it in those cloud-based platforms is something that is out of scope of this particular course. But it's not a big thing to learn. So possibly we can check with IAI in terms of some expertise in those areas as such. Okay, I am not from a non-actuarial background as of now. Yeah, not an issue. I mean, it does not matter. Data science is background agnostic. So even if you are not from actuarial science, fair enough. That should not be a limitation here. I will have to check with it on the point, Partha. I would possibly see how I can fit the same. Making a note of this. What kind of data set? Can we include using data sets from different other softwares as well? Yes. So we will be using Excel, CSV, Access database. We are going to use, but possibly we will include the SQL also, not an issue. Probably I may have to create a MySQL database and we will try to use from that MySQL database. It is very much possible, but Excel, CSV and Access, anyhow, I have already planned. Okay, so I mean, so here data science is something which would be leveraging all the various models, all the various learnings of the data. So possibly we can see some good applications trying to come out in the data science area. Reference books, yes, I am going to post them. How heavy is the math content? We will restrict ourselves to the application aspects. So there are some models where the math goes a little bit heavy, but we will try to restrict ourselves to keeping in mind the various participants from different backgrounds. Do we need to install any software? As I told you, if we are working with Google Colab, you don't need to install anything, Gaurav. You just need to open your browser and you say colab.research.google.com. Will generalized linear model included in the course? Yes. What about Spider Editor? You have, I mean, you can very well use it. I mean, so at the end of the day, each editor has a very few small differences compared to the other editors, right? Spider, again, if you have installed the Anaconda, Spider comes automatically with the Anaconda installation. So you can very well use the Spider or the Jupyter Notebook. Both of them come with the Anaconda installation. But you can, on the other side, you can very well use the Colab of Google. This is again a part of the Google Research Laboratory. So you can use the Google Colab, which does not require any installation and everything is installed on the cloud. Can you repeat how to start a new page? So you are going into the new page, new this colab.research.google.com. So all your existing files would be coming. And at the same time, you will get a new notebook. Or you can see the recent Google Drive. So if I am sharing some notebooks, you can share you can save them them into your Google Drive, and you can directly upload from, or if you are saving it in your system, you can upload them also. Or you can very well create a new notebook. The option is available at the bottom. You can open this. Anyhow, I have already platform has been installed, or which framework has been installed by the organization, be related to the topics covered, as there is no limited to. I think that's the real point, Sandeep, because so, I mean, if there is some small addition or deletion to the topic, we can very well do it. But definitely unrelated questions, let's try to restrict them, or we can have a separate call. You can give me a, you can send me a message. We will be there in the WhatsApp group, so you can send me a separate message and all, so we can try to address, because for data science the sky is the limit, and which means sometimes I may have to really do some kind of an external research to come back. Okay, I heard a lot of insurance companies are moving to cloud platforms like AWS. Yes. Uh, Frankly speaking, see, the algorithm will not change. The machine learning model will not change. The only thing is how it is deployed will have a big difference according to what I understand. Frankly speaking, I have not worked much on those servers, because so we have many such kind of servers: AWS, Azure, Microsoft Azure. So all of them, again, depending on which platform has been installed, or which framework has been installed by the organization. But the framework of machine learning, the framework of data science cannot change. So we are more focusing on the framework, and again using the tool like Python. But the implementation part of it in those cloud-based platforms is something that is out of scope of this particular course. But it's not a big thing to learn. So possibly we can check with IAI in terms of some expertise in those areas as such. Okay, I am not from a non-actuarial background as of now. Yeah, not an issue. I mean, it does not matter. Data science is background agnostic. So even if you are not from actuarial science, fair enough. That should not be a limitation here. I will have to check with it on the point, Partha. I would possibly see how I can fit the same. Making a note of this. What kind of data set? Can we include using data sets from different other softwares as well? Yes. So we will be using Excel, CSV, Access database. We are going to use, but possibly we will include the SQL also, not an issue. Probably I may have to create a MySQL database, and we will try to use from that MySQL database. It is very much possible, but Excel, CSV, and Access, anyhow, I have already planned. Okay, so I mean, so here data science is something which would be leveraging all the various models, all the various learnings of the data. So possibly we can see some good applications trying to come out in the data science area. Reference books, yes, I am going to post them. How heavy is the math content? We will restrict ourselves to the application aspects. So there are some models where the math goes a little bit heavy, but we will try to restrict ourselves to keeping in mind the various participants from different backgrounds. Do we need to install any software? As I told you, if we are working with Google Colab, you don't need to install anything, Gaurav. You just need to open your browser and you say colab.research.google.com. Will generalized linear model included in the course? Yes. What about spider editor? You have, I mean, you can very well use it. I mean, so at the end of the day, each editor has a very few small differences compared to the other editors, right? Spider, again, if you have installed the Anaconda, Spider comes automatically with the Anaconda installation. So you can very well use the Spider or the Jupyter Notebook. Both of them come with the Anaconda installation. But you can, on the other side, you can very well use the Colab of Google. This is again a part of the Google Research Laboratory. So you can use the Google Colab, which does not require any installation and everything is installed on the cloud. Can you repeat how to start a new page? So you are going into the new page, new this colab.research.google.com. So all your existing files would be coming. And at the same time, you will get a new notebook. Or you can see the recent Google Drive. So if I am sharing some notebooks, you can you can save them into your Google Drive, and you can directly upload. Or if you are saving it in your system, you can upload them also. Or you can very well create a new notebook. The option is available at the bottom. You can open a new notebook. That's it. So you don't need any specific installations here. That is the kind of an advantage that you get by using Colab. Okay. Does Google Colab or Kaggle need to install packages? Yeah, see, some packages, they come with the default installation of Google Colab, right? Possibly your NumPy, Pandas, Scikit-learn, right? These are all kind of packages. They come with the very basic installation of Colab itself. But for some specific packages, probably let's say you want to do some kind of financial time series where you want to pull out the data from Yahoo Finance. Now for that, you have to install the package, right? So it's like some packages are by default installed as a part of the default implementation itself, whereas for some of them you have to install them explicitly. Akash, since you are aware of data science from both R and Python aspect, I am R user and not used to Python. So as per R, we can install the basic R software and R Studio. Same things for Python, like which is the IDE, which we will be. So as I am telling you, for Python, we will be working with Google Colab. I think I have been telling Akash, we will work only with Google Colab. Otherwise, you can also install Anaconda and follow it up with Jupyter Notebook. So just like your R and R Studio, we can talk about Jupyter, Anaconda and Jupyter Notebook. But if you are using Google Colab, you don't need to use any one of them. There are a few changes between the usage of Google Colab and the Jupyter Notebook, which wherever possible, we will try to discuss them. Okay, few good books to study I will be sharing. Name of the main statistical topics required. Don't worry too much, right? If you know some basic statistics and inferential statistics, that should be sufficient. We will try to handle them in the context. Difference between ML and data science, just wait for a few minutes. I'm going to talk about it. In fact, ML is a part of data science, is one aspect of data science. Okay. Can we use VS Code? I'm not fully sure about it. Let me just Google it. Okay, Visual Studio Code. Yeah, but I haven't used it, Ashna. I'm not that equipped with that. Right, I remember using for long back for my Visual Basic or Visual C++ kind of programs which I wrote way back in my early years of career. But after that, I don't think I have used much of that. And I'm also making a quick disclaimer here, right? I am more of an applied person and less of a hardcore programmer. So possibly some of the aspects of a good programming language in terms of high efficiency, efficient program, or possibly the right a very clean kind of a code, etc. Sometimes keep missing in my program, because many a times I would always try to look out for how to execute this particular code for a particular problem. So always problem oriented functional programming is what I look at, though I keep referring to in terms of improvising the speed and improvising the timing aspect of the code. Sometimes possibly there might be much better algorithms which can be implemented at a much faster pace and which can be executed in a much lesser time as well. But just wanted to give you that kind of a disclaimer as well. But yes, in case you guys, some of you come from a good programming background and you would like to share your experiences, possibly we should use this platform even from that perspective as well. All right. So I think the questions are more or less done. So I would get started with the introduction to the world of data science. And possibly then I'll just take you through the first, the initial usage into the world of Python as well. So normally I don't use much of a PPT. Right, we will directly jump onto the data every day. We will try to address a few queries using our data itself. The more and more we practice practically, so we will try to understand the theory and the conceptual aspects within the context of a data itself. But the first chapter, giving you a very brief introduction, I have used the slides, but after that our work would be more and more restricted to using a pen and the marker, or possibly using writing it on the whiteboard, whatever are the concepts that we are interested in knowing. So few important things, I think all of us are motivated to join into this program. In our everyday life, we are constantly surrounded by the data, whether it is in the form of text, numbers, tables, audio, video, coming from smartphones, wearables, monetary. So everything is data for us. And nowadays, with a lot of computing power, lot of high performance computers, etc., the importance for data, understanding the data, those all became even more essential. Today, whatever is the field that you are into, how well you can understand and process the data is becoming the core. And the more you have mastered that skill of data understanding and data processing, possibly your value in the industry has gone up quite is going up drastically. So understanding how computers store the data, process the data, what kind of functions are there, what kind of programs can be used, that is what is creating a lot of importance in the industry, any industry today. And internet, cloud, wearables, IoT, lot of these new technologies, they are really changing the way the data is getting generated, processed, and finally being made available for taking decisions in the industry. So where is this data science coming from? What is the data science doing? It's a very important definition. First of all, it's a scientific field. This is from Wikipedia, but I really like this definition. It's a scientific field. So just like actuarial science, this is data science. So whatever are the aspects associated with science, they are associated with data science as well. Just like the way actuarial science is a separate science, dealing with risk by using the knowledge from various disciplines. Even the data science is utilizing the knowledge from data, a different discipline and a scientific way of solving problems. So it is using scientific methods. So we have, again, the methods are coming from various fields. They may come from statistics, they may come from information sciences, which is computational sciences like machine learning, etc. So it's a scientific field. It is using scientific methods. So which means what if data is scanty? What if data is not there? I don't have a solution. I'm going with a very stable scientific manner. So there is a scientific method to extract knowledge. So what is this doing? Its main objective is to extract knowledge. And that knowledge is actually providing insights from structured and unstructured data. So structured data is the data that is present in the form of tables, right, which is very well organized in terms of rows, columns, etc. Whereas unstructured is coming from the perspective of completely unorganized. It's not in a structured form. Like possibly here we talk about the data in the form of text, data in the form of image, data in the form of audio, data in the form of videos, etc. Right? So you could very well see that the data could be either in a structured format or in an unstructured format. We are trying to process that data. We are trying to extract knowledge and insights from that data using some scientific methods. So possibly some kind of out of the box thinking and all will not come as far as the method is concerned, right? But in terms of identifying the variables, in terms of engineering on the variables, in terms of creating new variables, etc., you can very well bring in the world of creativity. But when it comes to the method, it's a straightforward scientific method. And apply knowledge and actionable insights from data across a broad range of application domain. So we are talking about the data across a broad range of application domains. You can very well apply it to any data of your choice, right? So once you get some insights, you should be in a position to apply that knowledge to get some kind of actionable insights. So you should be able to take some decisions based on the outcomes that you are getting out of your various models. So that is what is the typical definition of data science. So I think this definition is something very well articulated, and it can define the scope of data science in a much easier mechanism. Now, when you are talking about, I think someone was asking, where does machine learning fit in? Machine learning is one of the various aspects of scientific methods. So you can very well bring in your other world of statistics. You can bring in scientific methods from the world of statistics. Machine learning can very well come as scientific method. But of course, nowadays, a lot of things get into the machine learning packages as well. So I mean, the gap is getting more and more narrower. But if you are strictly looking at so machine learning is nothing but it's a bouquet of scientific learning methods, right? So it's a combination of multiple disciplines, data science. So possibly someone who really wants to master the world of data science, they should have a good grip on statistics. They should be able to visualize the data better. They should be able to do all kinds of pre-processing on the data, understanding of the data. So they are becoming more and more, they are falling in love with the data. So it's a simple way of, so you go on a date with data, and you keep yourself completely immersed in terms of appreciating the data, the beauty of the data. Now that is where you would become a much stronger data scientist, and you're also trying to learn as many algorithms as possible, right? Machine learning is all about a bouquet of algorithms with various parameters. So you are trying to understand various algorithms, the parameters associated with each of the algorithms, what is the impact of changing each of the parameters, and typically at least to a high level extent on what is the mathematics that is going behind each of these algorithms. So you are using knowledge from all these areas to analyze data and extract knowledge and insights from it. That is where the data science is coming into picture. So you could see that this again picked up from one of the Google images itself. So obviously you need to have some mathematical background. You need to have some programming background. And along with that, it is very essential to have a domain expertise. So these three put together, right? If you are talking of actuarial science, you need to have actuarial science domain knowledge. If you talk about banking, you need to have a banking domain knowledge. So domain knowledge is one aspect that is very required, because what variables to be collected, what data needs to be collected, in what format it needs to be collected, in what format it needs to be transformed. You can bring in all those things if you have a good domain expertise. Then mathematics will help you in terms of framing a mathematical model, building relationships between the various data elements. So to build very good models, your knowledge of mathematics will become helpful. And mathematics and domain, possibly if they have to result into a solution, then the computer science programming is very much required. So you can see the overlaps, mathematics and computer science put together. Even if I don't know anything about the domain, if I am running some mathematical programs, so learning from the data, then it can become machine learning. And otherwise you could see mathematics and domain without any programming, etc. I can do a statistical research. And domain plus computer science without models, etc., mathematical models, etc., it comes as a data processing. And if I include all three of them, that is where the data science is coming. So basically, it's a very, very interesting way of positioning various fields. So someone has asked earlier about where is machine learning? Where is machine learning? So you can very well see mathematics and computer science without much of involvement of domain expertise goes into without much of a domain expertise goes into machine learning, statistical research, data processing. All three of them put together is data science. I hope now you got a basic idea. Okay. So yeah, now I think just to expand on the previous slide, the main goal of data science is to extract knowledge from the data. So as we really say, you understand the data to whatever extent possible. Try to keep looking at the data from various dimensions. You try to understand the data. Find some hidden relationships, right? That's the core. So which means that way it is still an art. Though we are calling it as a science, but which variables to use? What kind of transformations that I do on these variables? How between what pairs of variables I need to identify the relationship? Those things are still the art of data science. The science of data science is towards the end where you are saying, yes, build a random forest model, build the best fitting random forest model, build the best fitting artificial neural network model. That is the science part of it. But to go to that location, there is a lot of pre-processing that is being done. That is the art side of it, right? So it also uses scientific methods, which we have already discussed. Probability, statistics, they are all scientific methods. So it uses a lot of intelligence from them. The obtained knowledge should be produce some actionable insights. So the decision taking is one of the most important outcomes of any data science exercise. And we should see whatever, irrespective of the type of the data, I should be able to extract some kind of insights from the data. So that's where here we are going to work with we will work with images, we'll work with text, so that even a lot of unstructured data can very well be utilized. And the application domain, you should have a lot of expertise in at least one domain, because that is what will really help you. I come primarily from a finance domain, right? Of course, actuarial science also I do work. Though I am a qualified actuary, I have been mostly into the finance domain in the education sector. So I deal with a lot of data relating to the time series, the financial markets, a lot of things like that. But definitely from the insurance world also, I have a good amount of understanding on the data aspects of the insurance world. And of course, you can very well take the domains, other domains where you have areas of expertise. And so what are the problems? Now, overall, if you see, data science is about 4 different problems. Only 4 major problems. If you really look at the whole world of data science, what it is doing, one is understand. You have a large volume of data. You want to understand the data. You want to visualize the data, right? The historical data. What are the various aspects in that data? You just want to understand, right? You want to see what changes have occurred from the past to now. So here your objective is understand something. Of course, understanding is for a specific purpose, but you are restricting your problem only to understanding. Or you can have another problem which is probing. What next? So if I have to solve the problems of what next, there also I can use data science, which means I have already implemented a decision. What is the consequence of that decision? So what is the success before implementing that decision versus after implementing that decision? So you can very well explore the impact of a particular variable. How has it impacted the outcome? You can very well get into that probing of the reality. Is it really effective? Is the solution or a new variable that I am thinking of, is it adding value or is it a useless variable? So that is something that we can really look at. Then the third kind of problem that you can try to solve is the pattern discovery. So which two observations are very, very close to each other, having similar behavior, or having a completely different behavior, is an outlier compared to the rest. So these are all associated with pattern discovery. And the major thing that people do in a data science project is predicting the future event. So prediction problems, broadly, you could see a problem like a classification problems and or regression problems come under this. So if you really look at the problems that are addressed by the data science, generally we see that these are the 4 problems. So at the end of the day, you should be able to take better decisions. You should be able to predict something in a much more effective manner compared to the non-data science problems. And you should be able to identify the various patterns within the data. So these are some of the outcomes that I should expect, or probably at the end of this course, you will be able to master in these various areas. Now, why are we calling data science as a science? If you see here, there is an empirical element. Obviously, we said we rely mostly on observations and the results of the experiment. So every science should be having an empirical dimension in it. Anything that we call as a science should be, I should be able to perform the experiments on experiments, and then I should be able to observe the results, and I should rely on the observations and results. And at the same time, there should be a theory also associated with it. If everything is empirical, we'll still cannot call it as a science. There is a theoretical thing, because new concepts keep emerging from the relationships, from the existing scientific knowledge. So we are always deriving new concepts, new algorithms, new formulae, new models are getting created. So which means there is a theoretical dimension to it. Then there is a computational aspect. We are deriving and discovering new principles based on the computational experiments, especially in terms of the speed, in terms of the parameter changes, etc. And the fourth dimension is it is data driven, right? We are completely talking about discovering the relationships and patterns purely from the data. So that's where we say it's a science, but it's a new paradigm of science, because we have both. Apart from the empirical and theoretical, we are saying it is highly computational and data driven as well. So Okay. So you could see what are the various areas that you can look at, or you should. So databases, another relative of data science. So this purely focuses on how to store the data, how to structure it, so this is a separate field in itself. If you try to master it, possibly you can master it to a certain extent, but we have experts who work in the area of databases only. So they focus a lot in terms of structuring the data in a way that it allows faster processing. Different types of databases are there, structured data, unstructured data. We have different kinds of databases. So we are trying to learn more and more in the world of databases. Similarly, I mean, that is what is one more area that you can focus on. Similarly, if you talk about big data, that is the kind of a buzzword in the today's world again, you could clearly see how to store large volumes of data. Right? Can I store it in a CSV file? Can I store it in an Excel sheet? Or is the relational database RDBMS structures, are they sufficient to store large volumes? Do I need some other forms of databases like Hadoop structure? So if at all I have a large volume of text data, how do I store them? Right? So these are all very huge volumes of data, which is varying at a breathtaking speed. How do I hold all those kind of data in terms of volume, velocity, veracity? You can really see data coming in large volumes. How do I store? So that is the entire science relating to big data. So we are only calling them as relatives of data science. They are not the same as data science. Each of them is a specified field in itself. If you want to learn them, probably you can understand some basic aspects of each of these. But definitely they are an oceans. They are separate oceans which are related to data science. But definitely, if we are talking about a data scientist, they may not work day in and day out in that space exclusively. But yes, machine learning, yes, it's a subset of data science where you could clearly see build a model that will be able to predict a desired outcome. And as we have defined, the data science also, the objective of a data science itself is to extract knowledge from the data. So machine learning is one major way in which that knowledge extraction can happen by doing a kind of learning from the data. Artificial intelligence, obviously it is slightly beyond the machine learning. Right. So what we are simply saying is we are looking at highly complex models that mimic the human thought process. So in a large number of scenarios and instances, we see that unstructured data into structural insights is most of the times possibly you are getting the data from various, let's say I get, so when you are saying chatbots or some of these simple tools, you are getting the data in a form of a text, you are trying to process it, and you are going back to the solutions as such. And finally, data visualizations is also one more separate field of which is very, very much needed for data science, but you don't need to be a very high expert in data visualization. So this is the different types of data. We talked about it. Now, so the next thing that I want before we will actually get on to a little bit of Python code also today. So data science life cycle talks about 7 major elements. One, the first thing is about your business understanding. The more and more you understand your business, your domain, Possibly you can create a problem that can solve the needs much more effectively. Then data mining. You try to look at what data you require, how do you collect the data, what are the various sources from which the data can be collected. So there's a lot of data mining aspect that goes in. Then data cleaning. Whatever the data that you collect from various sources may not be in a position to use a model or to use to extract the knowledge in its original form. We may have to make a lot of modifications, lot of cleaning to that data. So data cleaning, we are going to deal with all these aspects here. Data exploration. So we call it as EDA, exploratory data analysis, which is very much an important element in before you build a data science model and draw insights from the data. The insights are going to be really insightful only if you do all these stages. Feature engineering, sometimes some here features are nothing but your variable. Some variables are useful, some variables are not that useful. Some variable will become more useful only when a particular function is applied on that particular variable. So you could see that feature engineering is one more essential element. We are going to cover all these aspects in much more detail as we move along. Then predictive modeling. Now, this is where different algorithms and all will come into picture. So before you jump into the predictive modeling, there are 5 steps apart from so along with your business understanding step. And finally, after the output is, so here data visualization, there are 2 elements. One, data visualization is already a subset of data exploration. Right? So there is one data visualization which is a part of data exploration, whereas the other data visualization which we are talking of after the predictive modeling has to do with the communication of the results. How well you present the results to a non-technical audience. That is where the way you visualize, the way you comprehend the model plays a very essential role. So this is what we typically call as a typical data science life cycle. So in case you want to become a data scientist, first thing, curiosity, 3 C's: curiosity, critical thinking, communication skills. That is what will help you to, so from a non-technical skills perspective, I say you keep asking questions. Once you look at the data, you need to keep asking more and more questions on the data. Critically explore through the data. You think it from out of the box. And coming to the technical skills, learn various machine learning algorithms, probably every month or every fortnight, every month. Some new extensions to the existing machine learning algorithms keep coming up. So try to follow them so that you can see if any of them are adding value to your data itself. Then mathematical modeling, the more and more you dive into it, possibly you can design your own error mechanisms, you can design your own parameters, you can design your own structure for the parameters, etc. So the more and more you know the mathematics behind each of the algorithm. Statistics, definitely it can really help you. And databases, the understanding of the databases such as SQL and unstructured kind of databases also. But of course, there is no end to what you can learn. So possibly you can always position them in a step-by-step approach as such. So this is what is the minimum thing that you need in data science. Something about math and stats, coding skills, Python R, data wrangling and pre-processing, data cleaning, data pre-processing, etc., data visualization, machine learning, communication, lifelong learning, because the new models keep coming up every fortnight. So you should be in a position to upgrade yourself. And of course, if you have to build some exhaustive and extensive data science projects, obviously it's a team effort. And at the end of the day, there are lots and lots of ethical dimensions that play out here. Business intelligence, possibly we may not require. Business intelligence is purely about the past data. So you're not building mathematical models, etc. So most of the times you have the data that is lying in your databases, and you try to visualize the data using business intelligence. So you don't work too much of unstructured data in BI. Whereas when it comes to data science, you work a lot with not only the structured data, but also with the unstructured data. So you use only a historical data analysis, whereas in data science, we try to find relationships between the variables. We try to find patterns, abnormalities, all these things within the data. So normally, BI to a large extent is about tabulation and visualization. And you do some basic statistics, descriptive statistics to a large extent. Whereas here we talk about machine learning is one of the most important skills that we require in data science. And past data and present data, whereas we also go for future predictions when it comes to the data science. So this is a very brief introduction to the world of data science. Now, what we will do is, we will try to get started. So I'll just open up for some questions. So in case we don't have questions, we will just try to work a little bit with Python. So at least this is purely targeted for people who do not have much of expertise or understanding of Python. So I just have formulated a small module which can really help you in terms of getting started. I'll share this book with you after the class. Possibly I'll share it to Ravindra, and he'll again share it back to you people. So instead of me typing in there, I have already created the book so that we can learn. So for you, if you have to create it anew, right? So we are talking about Google Collaboratory, and you can very well create file new notebook. Okay, so by default, it comes out as untitled. You give a name, right? Possibly you can say test. Now here you can put two things. One is you can put your Python code. Two, you can put your text, right? So you could see if I put a text, you will get a text editor. So you can say this is my Python code. Now you can do a lot of these things, all text related, right? Let's say if you want to bold this. So this is nothing but 2 stars on either side will make this as a bold. If you want the italic, you say is, and you put a single star, it becomes italicized. Then you can very well say by. So if you are now talking about the heading 1, then you put 1 hash before it. Or you can directly take help of this. This is like a heading 2. This is like another heading 3. So you can even put, right, then you can very well say, my name is Vamsidhar. Okay, so these two things, let's say you want to put it as serial number, you can very well insert them as, so possibly you can put that as a serial number and you can put it into the list. Right? So if you execute it here, you will find that you can put a serial, I mean, you can put a list, you can put in bulleted points. So this is about your textual part. So whatever the text you want to write, you can very well say insert text and you will get a text editor like this and you can write. So which means some kind of comments to the Python code you can very well write by using the text. And the other option is you can put a Python code as well. So we will, rather than we trying to write, so probably the Python code is very, very straightforward. Possibly you see a simple arithmetic like 2 plus 3. You just click on the run. I think it is taking some. I think I have something stuck out here. Possibly, yeah. Okay, yeah, it has taken some time, but that's okay. So when we do it from the next time onwards, so let's say if I'm putting something, so it works as a basic calculator to start with. But yes, let me take you through some of the code, which is explaining you about some introductory aspects of Python. But before we jump into it, anyone, any queries on the conceptual aspect that we have discussed? And possibly you to say that Python is working for you, you do this exercise. You open, I'll give you 5 minutes. You open collab.research.google.com. You open a new Python notebook. And in that, just try 1 or 2 simple things. And in case you are able to get it, then Python is working fine on your machine. So we will then try to run our regular code. Okay. How much knowledge of computer science is required for data science, programming, or something else? Yes, I mean, typically programming is one aspect, but more than that, the algorithms. The concept of algorithms again is associated with computer science. So the knowledge of the subject called data structures and algorithms will actually be helpful. And apart from those two, I'm really not sure if any are. Sometimes you have something called graph theory. I mean, they all come in algorithm, automata theory, etc. So regular expressions. So there are a few concepts definitely that come from the world of computer science. But yeah, definitely you don't learn them in the same way that a BTech computer science guy is going to look at. What is the usage of text editor? So which one are you referring to, Raymond? Are you referring to this text here? Or any text editor is what that you are talking of? In Colab, the text is to give beautification, right? I can write notes also. Sometimes in a notebook, I would like to integrate both code and now you see here, I have written like this. I have put a heading called about Python and I have written some notes here itself, right? I have written some kind of notes here itself. And that is where sometimes it can be of help. Okay. Yeah. Apart from linear algebra and probability statistics, what other fields? Probably a little bit of calculus is required because we talk about gradient and so some amount of basic calculus comes into understanding. Linear algebra, probability statistics, and a little bit of coordinate geometry. Because we would also be talking about the concept of distances, etc., which again can be linked to linear algebra. That's it. But of course, a little bit from here and there, but majorly these are the areas that we would be using. How do we debug in Colab? So these are all interpreter-based languages, right? So you would typically you are writing one line of code and you are typically executing that line of code. So basically, wherever it gets stuck, the error message that it drops in is more and more comfortable. But you can also try something called exception handling. And so wherever you find that there is a scope for a problem, you can put some exception handling mechanisms there so that you can catch. So you can use a try catch block to try to identify where exactly the problem can come up. We'll see as we move along. We are going to have a little bit on matrices and the basics of linear algebra. Right, so we are going to spend one session on the linear algebra part. Calculus, when we are talking about, I mean, we don't get detailed into right. We will introduce calculus to whatever extent that is required for computation of for understanding the gradient and the gradient descent kind of algorithms or gradient descent kind of approaches. All right. Okay, so what I suggest is everyone able to test this on your system? Anyone having any kind of issues, please do let me know. You should be able to enter both the code as well as the text. So just try that out. At least people who are very new to Python. Anyone facing an issue, just mention it. If you are not facing an issue, fair enough. But if you are facing an issue, just let me know. A network error occurred. Just Google it out. So it's many a times, any error that comes out, try to Google it out. So it is saying consider restarting your browser. So just try them out. Sometimes, I mean, not every problem will have. So people would have faced this problem in some form or the other. Just Google out, it should work fine. Okay. So now that it is working, I'll take you through the very basics. So probably you could see here. Oh, where did I link it? So we are getting started with Python. About Python. One, it's a general purpose programming language. I have already told you earlier. So this notes I can give you. So it is a general purpose programming language. So here I have mixed both the text as well as the code. So initially I have the text and after that I have the code as well. Right? So I'll showcase to you. Yeah. So we'll go step by step. It's a general purpose programming language. So which means I can create apps with Python, not necessarily statistical analysis, not necessarily machine learning, right? I can create apps with Python. I can create different applications in Python. I can create web apps with Python. So possibly whatever you can do with Java, C, C++ earlier, you can do most of the things with Python as well. So that way it is called as a general purpose programming language. One, it is interpreted and it is not compiled. I don't know if some of you have worked with C or C++ or Java. They are mostly compiled languages, or even the earlier ones. They are mostly the compiled languages. So which means or possibly if I talk about interpreted, you can write one line of code and you can execute that line of code. So one by one, line by line, the processing happens in an interpreter-based language. Whereas in a compiled-based language, it's not a line by line execution. It's an entire block is compiled and then executed. Now that way, debugging becomes a much bigger problem in a compiled language. Where exactly you have gone wrong, because all the blocks, all the lines of code are executed. First, a compilation happens, then the running happens. Whereas in interpreter, the running of the program happens line by line. So that way, even if you are not from a good programming background, learning the interpreter-based language is much more easier. And both dynamically typed. So when we are saying dynamically, you can very well, you can very well automate a lot of aspects using Python. And you can very well have a strong typing as well. You can actually bring in more and more syntactically kind of, so you can bring in both functional as well as object-oriented aspects into the world of Python. So we generally talk about Python 2.7 version and Python 3.x right now 3.9. So you can use right now, most of the applications are using 3.5 and above. But let's say if you had some old code written by possibly something in your organization which is using a slightly older form of code, then it should be in Python 2.6 or 2.7 kind of version. Some functionalities of 2.x may not be compatible with 3.6 and 3.7. So that's one thing. Possibly if you have some old code, sometimes some part of the code may not be working in the new environment as such. Right? Now, why Python for data science? We have already talked about a lot of things. So it's a general purpose language as opposed to R. Faster idea to execution to development. And it has been very much tested in various domains. And so it's very much robust now. And the most beautiful part is most mature libraries are there for machine learning. There are very mature libraries like scikit-learn, TensorFlow, H2O. There are more and more mature libraries for machine learning, right? So let us try some basic things. So this is a very simple code that you can think of. Most of the programming languages, they start off with this called print. So anything that you want to print, you can very well use this command called print with 2 brackets. And within the brackets, if it is a text, put single quote or double quote, doesn't matter. You put a single quote or a double quote and you can type whatever the text that you want. And once you type it, either you click on this run symbol, or you click on shift and enter. You do a shift and enter. That line gets entered, that line gets run, that line of code will get run, and you will get a tick mark next to that. So which indicates that the output is running. Okay, I have a few questions, looks like. Yeah, I will recommend some data science. See, basically you can refer to, if you want practical based books, you can refer to the books from O'Reilly publications. So in O'Reilly, we have different data science books, right? So one is O'Reilly publications, or the second one is Pact publications. These are not that great when it comes to the theory, but they give you the practitioner's approach, right? But if you are looking from a theory perspective as well, possibly O'Reilly can focus a lot on a combination of both theory and practice, whereas Pact publishers, PACKT, and A-Press publications, they also are dealing more and more with they deal with more and more of coding based, which is like a practical driven, without much covering too much of a theory base of each of these. Wiley can cover a lot of theory. So the publisher's focus is more and more important here. If Colab is web-based, we would not be able to use it with our organization's data to work on. In that case, you should install Anaconda and Jupyter Notebook. Yeah, see, the Colab can very well be, I mean, whatever the output file that you have, you can very well download this output file. Right, whatever, sorry, not the output, the entire Python file that you have created, you can download it as 2 things. IPYNB is nothing but IPython notebook, which is compatible with Jupyter Notebook as well. Whereas .py is a normal Python extension. So even if you are using Spider or any other editor, you can very well download this as Py. So what I will do is, I will be sharing these IPYNB files, which is the Python notebooks, IPython notebooks, and you can very well open them in Google Colab, and you can either download them as .py or .ipynb to use it in your local environment. All right. Okay, I think our friend Ankit Pandey is not able to do it. Are you still facing the problem, Ankit? So just try it. In case you're not successful, probably sometime tomorrow we should be able to plan. I mean, you can connect with me tomorrow. You can share your screen and possibly we can look into it. Yeah, when you come out of Colab, the code will automatically be saved. The only thing is it will always be showing untitled, right? So if you have already given a new name to it, that should be fine. It will be automatically saved. And possibly last few seconds or something might get just like a Google Docs. So I think a few milliseconds, few seconds of data might be lost. That is what is my understanding. But to a large extent, there is an automatic saving. Okay. Error message coming on print command. So you have to mention that message, then only I would be able to get. So when you run it, it should print simple. Okay, very good thing, Nikhil. Python is case sensitive. All the functions that you are giving, they have to be given in their original case. So for example, print. Print is a reserved command. Print with brackets will be printing out whatever is the text or whatever are the numbers that are there within the bracket. And print has to be given in all small letters, no capital letter. But now you see, you can practice it parallelly. Let's say if you are giving a capital P, print is not defined. So this function is not there at all. So probably you would see sometimes the help that you will get is you can search on Stack Overflow. Stack Overflow is like a forum, right? It's a big repository of common errors that people have faced across the world and the general solution that people themselves, other people have suggested for these problems. So sometimes for some weird problems, you can very well search in the Stack Overflow as well, and you will get a very quick solution as such. All right, so print should always be with a lower case. Okay, so now we will look at some basic things. Strings. So initially we are talking about, we will go step by step now. In Python, okay, if we are looking at in Python, the first thing that we are looking at is different types of data. Different types of data. So possibly if you look at different columns, so we typically call columns as sometimes we call them as variables, right? And sometimes we have the rows. Let's say we call these rows as observation. There are so many other words also, but I'm using a very basic word. Now, any data So it could be in the form of single column, multiple columns, single row, multiple rows, etc. So we see that broadly, either the data could be in the form of strings, which is in a text form, or it could be in the form of numeric. Of course, there are many more sub-classifications. Under numeric, possibly someone may say integer or float, right? Or Boolean. I can very well talk about many things. But on a broader note, I am saying strings and numeric. Now, these strings, we will be seeing what are the various operations that are associated with the strings. So we are just now looking at the very basic form of the data, right? I'm not started off with handling an Excel file or CSV file. We are just talking about the basic construct. Any data that we talk, like the hello world that we have looked at earlier. The hello world is a string. It's a text that is there as a data. Whereas 23 is a numeric. So we are talking about two such kinds of data. One is hello world, which is just a string. Two is numeric. So these are the two major kinds of basic data types that we are talking about. Right? Within them, again, there could be integers, there could be a floating point numbers, lot of things. But on a broader note, of course, date is another construct. Possibly, I could take the data type date separately, but right now I am not handling the date here. I'm only looking at string and numeric. So in the string, I will talk about how to create a new string. What do I mean by variable and the assignment of the variables? Then we talk about string indexing and slicing. These are some of the things that we'll do in our next session. Then string concatenation and repetition. So basically, whenever we come across a string and I want to manipulate a string, these are some of the things. Or possibly for today, I want to just do this. We will work with a few strings. I want you to really look into them, right? So if you see here, the basic data types, variable and scoping. So strings is what we will initially look at. So let's directly get into the code. I will again come back and we will discuss that part. Print. Sometimes I can print just a single word. And if I'm just using a simple blank print, it is actually creating one space. And you can also print an entire phrase. So all of them, anything that you put between the single quotes or double quotes is doing the printing part. So you can say, so this hash is like a comment. It is like a notes for you within the code. So you can put it above the code or you can put it to the right side of the code, doesn't matter. Now let's say if I put, now you see if I run this, first it will print this hello. Then there is a print with a blank. So it is not, it has printed a space. And then this is also a string is printed. But let's say if I put a hash here itself, which means this entire thing is taken as a comment. Now, if you run this, you see there is no gap between hello and this is a string because there was an extra print earlier, which was creating the gap. Right? Now, we can also create some variables. We can also create some variables. Variables are some placeholders. In the programming world, any variable that you are creating is a placeholder. So which means just you look at it. I'm actually creating something called small s. I'm assigning that to a value. So this is a variable. Anything on the left hand side of equal to is a variable. If I'm just giving some name, so I don't need, I can say Vamsi equal to New Delhi, or I can say city equal to New Delhi. So city is the name of a variable. So you can give anything. There are only a few restrictions in terms of what you can give as variables. So you can simply say yes equal to New Delhi. So which means you have created one. So possibly in Excel, you can say it is equal to one cell. So one location in an Excel cell called yes. And you have given it a value called New Delhi. Then you are saying print S. So here you don't give quotes. If you give quotes, it's like an explicit text that you are trying to print. But if you are printing a variable, you will not give the quotes. You will only simply say the name of the variable. Then I'm introducing another function called type. Type should give me string. So types are string, integer, now numeric. These are the different types of data. So when I say type, it should give me, so basically if you see here, if I am printing yes equal to New Delhi, print S. So it is printing New Delhi. Print type of S. It is printing string. Print length. Length is nothing but it is counting how many letters are there. So even a blank space is treated as a letter. So you can very well say New Delhi is containing 9 characters in it. So this is how you can think of one, creating a variable, printing the variable, printing the type of the variable, printing the length of the variable. So these are some more things that you can think of practicing. Right? I don't want to rush in here. So I'll stop it here, but I'll look at some of the questions. Okay, which publication is better for this course? You can very well look at either a packed publication or orally. Orally should be much better because it contains some theory also. So you can look at any data science book from orally publications also. Okay, is it possible to concatenate 2 or more print commands into one command? Yes, we have that. So just wait for tomorrow or until the next class, or I will share this first notebook with you, which also contains the concatenation of the 2 or more print commands into one command. No, New Delhi actually has a space in between, Kondababu. So even a white space is treated as a character. So basically it has 9. So if you don't want that, you have to write some operation again on the top of it. Okay. So let me see in this also. Is this comment only be useful to the programmer or no? I mean, if I share it, even you will be referring to it, right? So comments are useful for everyone because they would be there in the code. Even if you are exporting that to a PDF or something, the comments would be available there as well. So that way, if someone wants to read what exactly is being done, probably the commands are the most useful thing to work with. All right. So we will discuss I just wanted to get started with the code part of it. So tomorrow again, like the next, how to save my work. So it is auto save. Otherwise, you can very well save a copy in the drive, or you can simply say save. Type command, okay, we will discuss it. Type is, it is only telling you whether it's an integer or it's a string or it's a date, it's a boolean. So it actually is telling you what is the type of that particular data. Okay. So we will, the more we practice, so the next class is completely about Python notebook only, right? We will open this and we will try to execute it here and here itself. So possibly after the next class, you will get more and more clarity. I will share this notebook as well. All right. Yeah. Thank you, everyone. I think we will wind it up here. But yeah, any feedback, please keep posting to me so that if something can be incorporated, I will definitely incorporate it. Does it remember the last few commands so that we need not type print every time? See, we don't print many a times, right? Possibly we will see, I mean, right now we are started off with a very basic command. So we are printing, but everything that we store in a variable is remembering only. So we don't need to print always. We will see as we move along, Deepak. Okay. Yeah. Thank you. Thank you, everyone. Any particular reason why we are using Colab? I mean, last time when we have used Jupyter Notebook, we found a lot of installation issues from different people. So that could be one reason. But otherwise, I think, we don't need to use the resources of our system. So that's one more reason, but nothing beyond that. You can very well use your own. Okay, you can very well share it. Yeah, thank you everyone for your. Yeah, Jupyter works the same like Colab. Only a few differences are there, especially when you are working with CSV files, etc. Which I would highlight that wherever required. But otherwise, the actual code that does not have too much of a difference. Yeah, the notebooks, I'll send it to Ravindra and he will in turn be mailing it to you people. Yeah, thanks a lot, everyone. Thank you very much. See you on Wednesday. Take care. Thanks for your interest. Take care. Bye-bye.